Let's talk about the clock angle problem. This is an analog clock. Many of you may not have seen one of these, but this used to be the way clock handles used to look. The alarm clocks and regular wall clock and so forth used to look like this. So it is an hour hand which goes around once in 12 hours, and it's got a minute hand that goes around every hour, and it may possibly have a second hand to measure seconds, which tend to go around for 1 minute. So we want to find the times during the day at which these clock handles, the hour handle and the minute handle, would be on top of each other. It'll happen at 12 o'clock because the hour hand and minute hand is exactly at pointing towards 12. Now obviously sometime after 1 o'clock, but before 2 o'clock, the hour hand and the minute hand are expected to come one over the other, and we could possibly guess there'll be around 11 such positions. Now let's try to see if we can figure out what those times exactly are. So to do this, let's say we write a code to figure out what those exact points would be. So to handle this, we create some variables, and the first is the number of degrees by which the hour hand will move in an hour, and that's h angle, and the amount in degrees by which the hour handle will move for a minute, that is mh angle, and sh angle is how much the hour hand will move for a second, and m angle is the amount the minute hand will move for a minute, and sm angle is how much the minute hand will move per second. So that's going to be a very tiny amount. And s angle is the amount a second hand, if you have a second hand, will move in 1 second. So with these variables defined, and as you can see, the hour hand is going to move throughout this 360 degrees in about 12 hours, and that's why you get that value. With this, let's consider every hour 0 to 12, and 0 to 11 hours can be between 12 o'clock onwards till 11:59. So 0 to 59 is the minutes and 0 to 59 is the second. So for every combination of this throughout the day, we will apply this function. Now notice the application operator. What application operator does is that you take the array on the left, and for every combination of arrays within that array, so for example, hours is an array, minutes are in an array, seconds are in an array. So if you were to take all these combinations, and this function will be applied to each combination of that. That means for every hour, minute, second combination in this set, this function will be called. And then what we are doing is, inside the function, we calculate how much did the hour hand and the minute hand and the second hand move for the given hour, minute, and second. And then you calculate the amount the minute hand will move for that particular combination of hour, minute, and second, and see if there is a difference between the two. And if that difference is less than the amount the second hand would move in a minute divided by 2.01. And the reason why we do this is to simply avoid the fact that this matching is going to happen in some particular second. So that second, the minute hand would have moved slightly. And to catch those situations where the second hand, the minute hand moving during those seconds, we put a limit on it, saying that if the difference between the hour hand and the minute hand is less than a very small amount as our limit. Now if I put it as 2 to start with, you would see that in our results, keep this as 2, that is, take the angle that this minute hand will move in a second, you divide that with 2, and if you use that as a limit and you run this program, you would see that it tells you the times at which hour hand and minute hand come one on top of each other are these, and that kind of matches with the preset answer that is available on the internet. The times would be 1 hour, 5 minutes, 27 seconds, which is correct, 2 hours, 10 minutes, and 55 seconds. And there's a little problem, because for both 2 hours, 10 minute, 54 and 2 hour, 10 minute, 55 seconds is so close to each other that both are reported as results. So that's why we apply this additional adjustment, so that this factor is going to be even smaller, so that we will not have two results for the same hour as we had for 2.2 hours, 10 minutes and 55 seconds. Now, as you can see, all these results are exactly as what we would expect in this situation, and 000 is basically 12 o'clock. Here we stop at 10:54:33 because 12 o'clock is the same as 000. So that's how we find the exact times at which the hour and the minute hands would meet in an analog clock. Thank you.